Hello, everyone. I hope all of you are doing fine. Welcome to the session of Machine Learning in Production, hosted by MLOps World. My name is Aarti Malhotra, a PhD student in AI at University of Waterloo, Canada. I'm glad to be the moderator for today's session. I'm honored to introduce Dr. Matt Zeiler today. He's a founder and CEO of Clarifai, which is a deep learning AI platform for computer vision, natural language processing, and data labeling. He received his undergraduate degree at University of Toronto and a PhD in machine learning and image recognition from New York University. Dr. Matt has worked alongside renowned machine learning pioneers Geoff Hinton, Fergus, Yann, LeCun, and Geoff Dean. This experience cultivated his passion for convolutional and deconvolutional neural networks and visual recognition. He won the top 5 places in image classification at the ImageNet 2013 competition. May I now request Dr. Matt Zeiler to enlighten us with how to deploy efficient data-centric AI 100 times faster in production. If anyone has any question, please feel free to post the same in the chat. We will have a Q&A session after the talk. Over to you, Dr. Matt.
Great, thank you, and thanks for the kind introduction and having me today. So welcome, everybody. Today, I'm going to walk you through how to really make AI world-class while doing it very efficiently, up to 100 times faster than you traditionally do it. So a little bit about us. Some of this was covered. I founded the company about 8 years ago, won ImageNet after founding it. And also that kind of put us on the map as having the world's best image recognition from day one, which led to a lot of great investors investing in us. Qualcomm, NVIDIA, and Google in our seed round invested. And then Union Square Ventures led our Series A, and Menlo Ventures led our Series B, and a bunch of other great investors along the way. We've also been named a lot of different awards over the years, starting with ImageNet, but then more recently named a leader by Forrester in this space of computer vision platforms. And it's really exciting because the other 3 leaders are trillion-dollar companies. We've really broken away from other startups in the space, and that's just a testament to how customers view us as well. And so it's really awesome to see. And one of the big reasons for that is we have a dedicated research team that pushes the limits of AI, and alone they have 170,000 citations. So we're really building cutting-edge AI into our platform. A variety of other awards won over the years. We have a lot of focus on government. We've become the best AI product in government. And we try and make Clarifai a great place to work as well. So we've been recognized for that. In terms of what sets us apart in terms of our platform, we like to think of us as being the quickest way to really get AI up to production quality and understand your unstructured data. We've actually moved beyond just computer vision, where I started the company, to now understanding text and audio. So collectively, we call that all unstructured data. So we have cutting edge audio recognition and NLP models available in our platform. We also make the platform very environment agnostic. We can run fully hosted for you in our AWS cluster. We can run on Azure and GCP. We can run on your own bare metal machines, even in air-gapped environments where there's no connection to the internet. And with some of our offerings, we can run on the edge on low power devices like NVIDIA Zeiler chips. We also don't compete with you. This is a huge problem that the tech giants end up bringing to the table when they're talking to you about AI. They also have retail divisions, advertising divisions, media, insurance, you name it. They're pretty much competing with every one of their customers. Whereas with Clarifai, we're here to solve your AI problems and be an independent player in this space. And so we can really lock arms with you and solve them together. We also pride ourselves on making it really easy to use. It's powerful enough for data scientists to tune enough knobs to get the most out of the platform, but we don't require you to have any experience in data science. You can be a developer, and with our user interfaces, you don't even need to be a developer to build the AI, which you'll see today. And we've become the industry experts. Having done this for 8 years, we've been solving tons of different problems for our customers. And so the way the platform manifests itself is all encapsulated in this diagram. If you look here in the middle, it really starts with your input data, images, video, text, and audio. And then along this row here is the complete AI lifecycle within our platform. And we make this just a few lines of code for each of these to interact with in terms of our APIs, and then really easy to use UIs on top of that. And that process starts with data labeling. Typically, when you have your unstructured data, you need to label it so that AI can learn from it. And we built Scribe last year to be 100 times more efficient than other human workforce tools in this space. And we do that through the automation with our AI platform. So we can automate most of the work away from humans, and you can use that with your humans, or we have a fully managed service called LabelForce, where you just send us the image, video, text, or audio, and we'll label it for you based on your instructions. All that data is indexed in spacetime, which is a powerful search index, which lets you query by human annotations, AI predictions, and even visual similarity search to find things that look similar to a query image, which is a really powerful tool that people like Lowe's, the home improvement chain, have built right into their mobile app. So you can try it out yourself. Also, we have all the training tools and evaluation tools, which we call Enlight. And we built Enlight to be very efficient at learning new things. So it can learn from just a few examples and in a few seconds how to recognize what you care about. All of those models that you're training are actually versioned in our platform. Every version can be evaluated to see which ones are better. And then every version is immediately available in our model to serve up predictions. And this is where we've really eliminated the DevOps around AI. And so you never have to think about even deploying models. There's not even a deployment button in our platform. And then finally, we have mesh workflows, which let you chain together multiple AI models to do more in our platform, which is a really powerful concept that you'll hear more about today. All of those run across all the major clouds on bare metal, and then Flare pushes this to the edge. So we can run on drones, CCTV cameras, etc. We're also HIPAA compliant, SOC 2, so we can work with large enterprises. We have a big government presence. We even have facility clearance, so we can hold security clearances. And on the top here, you're seeing a variety of different use cases. We can moderate content, filtering out drugs, nudity, weapons. We can tag content to improve search. We can do a lot of intelligence, surveillance, reconnaissance types of applications from drones and satellites. And we have a lot of work in predictive maintenance and quality control on manufacturing lines. And so let's take a look at how you can do this and do this very efficiently. So we like to eliminate all the bottlenecks in building AI. We've have a lot of experience in doing that over the last 8 years. And even before that, some of us that have done PhDs really had to build the whole toolkit, build the whole pipeline for training AI models in order to do our research. So we've learned a lot of lessons along the way. And so we like to have all the tools in your disposal so that you can focus on the fun problems and solving AI problems rather than building the infrastructure. And that revolves around your data. We like to be able to manage your data as it scales. We run it in all compliant ways to adhere to HIPAA, SOC 2, so you don't have to think about the security aspects. Everything's versioned, so you can roll back and reproduce results. And you can do this all very efficiently. And this is why people like Flipkart are using us, where Flipkart has now trained over 1,000 employees within their company to be able to use our platform end to end. And the result of that is they've trained over 100,000 models using Clarifai. And this would not be feasible if they tried to use open source tools or any comparable, cobbling together of different vendors. Having this all cohesively in one platform gives them a huge leg up. And that's why they've adopted us to organize their product catalog and to moderate it as well. So let's take a look at these tools in more detail. And we'll start from kind of running your final model in production and working backwards to how you would actually build a model like this. So our model is how you run the model and you never have to think about it. It keeps your model up 24/7. It really eliminates the need for ML ops or DevOps. And the way it works is as we get more requests going to your model, it'll scale up more replicas to handle the extra traffic. When it gets less requests, it'll scale down to 0 replicas and save resources, which honestly, just at the end of the day, saves money, especially when running on bare metal. You're not paying for those extra machines and compute. It also supports third-party models. So if you've been building a model outside of Clarifai, you can now work with our team to upload it into the platform. This is a new alpha feature we've built. So we want to get your feedback. It's a very complicated thing to solve in the general case. So we want to work closely with you. And this allows you to run your models at whatever scale you need to. So let's take a look at what this looks like. These are actual Datadog metrics of traffic coming to different models. Each model is a different color here. So you can see the number of requests per second going to models. And all of a sudden we get a big spike in traffic. and the models and number of replicas have to handle that. And it wasn't just a spike with one model, it was a spike at multiple different models at the same time. So it's a difficult scenario to scale to. So at the bottom, you're seeing we're reacting very quickly within seconds to scale up more instances of the models in order to handle that traffic. When you see the scaling happening, you'll see the latency of your requests for these models, especially models that are coming out of kind of cold storage. They didn't have any replicas. Those models will take about 10 to 15 seconds to respond to that first request. But you don't have to manage that process. You just send the request and it'll come back eventually. After that first request, then there's a model replica that's already live, and subsequent requests will be like 100 or 200 milliseconds, typical speeds of our API. And you can see it's not just the number of replicas. All of the platform is running inside of Kubernetes. And so as we scale up the number of model instances, the number of pods that are holding all these models actually scales up as well. And we can actually add more machines dynamically as well. So here you can see the number of pods within Kubernetes scales up to match that traffic. And therefore you can see this could infinitely scale. And you never have to think about the DevOps ever again. It'll also scale down number of replicas. I don't think these, so here, the yellow, it kind of overshot when it got a little bit of requests. It overscaled the number of models to be safe. And then once it realized it didn't need that many, it actually downscaled to just a couple replicas. So this is the up and down scaling. You never have to think about it again if you use Clarifai. So now how do we train those models? How do we build really great models that can actually be useful to the world? That's where Enlight comes in. And this is built as a bunch of different model templates. So you can either use some of our pre-built models that Clarifai has provided and have trained on thousands of concepts and millions of examples. So let's take a look at some of these pre-trained models. You can see them right on our website. If we take a look at the general model, this is one of the first models we've ever built, and it recognizes 11,000 different things like objects, water, boat, reflection. It can even recognize really high-level things like love, affection, togetherness. So this is trained on about 10 million images for these different concepts. To do other use cases, we have other models like moderation is handled by this model that does drugs, gore, etc. So these are really the quickest way to solve a use case. They're already ready to go, and within minutes of signing up, you can start using them. But the fun comes in the customization that you get from Enlight, where you can actually start building your custom models automatically. So with these pre-built models or custom models, the prediction APIs are the same. We make it really simple to be able to call our API. We have clients in many different languages at this point, somewhere around 10 different languages. In our documentation, which is at docs.clarifai.com, you can check out all the different API clients and different code snippets to get you up and running on using our API. So here we have links to all of our different API clients. And then if we take a look at making a prediction, you'll see that we have examples in some of the popular languages like Python, Java, and curl to get you up and running. So you can literally just copy this, throw it into your code, and you'll make a prediction. You just have to fill in some of the key things we have here in all uppercase, like the model and the specific version of the model. And then you put in your data. So we can take it as URLs, we can take it as base64. And this is an example of an image, but you could just as easily swap this for video, text, or audio, and it's the same process. So very easy to use to get these models into your software. Now, we also have this capability of visual search that I mentioned earlier. And you can think of this as a really powerful tool to discover content. You can also think of this as a way to do classification, like k-nearest neighbor type of classification based on using a query as the input, and then it'll return a list of results, and you'll be able to find stuff that looks visually similar. And so this is a scenario where you can do what Lowe's is doing. Okay, so here's a scenario where you might have a bunch of hiking shots from your friends or family, and you want to see like, oh, like, what is this backpack that I see in this picture? I really like it. I want to find more of it. So using that as the query, because I don't know what to search in terms of keywords to find this, I might be able to look up in a product catalog things that look similar. And so on the right, we're picking a different catalog of images, not the hiking photos, but a product catalog. And we're finding that it actually finds an exact match of the same type of backpack. And I didn't have to even know the brand name. I didn't have to search for like hiking backpack or whatever the keywords might be. We automatically find that using the query image. So that's the power of visual search. And as you can see, if you just took a threshold on, those search results are all scored. So you can do a threshold on the score and take the top results and their categories and use that as a classifier as well. And you didn't have to train anything. So that's kind of instantaneous training without any labeled data. Now, to train models with labeled data, there's two different ways to do that in our platform. You can do context-based training, which we'll learn very quickly with very few examples. And then there's deep training, which takes more time because it's training all the way up from your input data to your output format and starting from scratch. So the context it's like an adult brain. The context has a lot of context of the world. It can learn something new very quickly. Deep training really doesn't have that context. And so if we want to take a look at how quickly things can learn, I'll show you what that looks like in my personal pictures. So here's an app in our platform. You can see there's actually a variety of different apps in your user account. If I just go into this first app, this is my personal photos. At the top level of an app, you can create API keys. All of these are very fine-grained. You can control all the way down to the API endpoints, every single one of them, what you want to be able to access with that key. You can also invite your friends and colleagues to collaborate. And when you invite them, you can control their access all the way down to every endpoint as well. Adding data to the platform is really easy. You can literally drag and drop. You can put in URLs, etc. And once data is uploaded, it looks like this. This mode is for exploring your data, where I can perform some of these searches. So I'm going to go find pictures of dogs. And these are my personal pictures, so I get to see my high school pet, Rolly. Now, if I want to teach the system with context-based learning, we already know a lot about dogs, so it should be able to learn about my dog specifically pretty quickly. So I'm going to grab a few examples and label him Rolly. I could type in whatever concept name I want here. I've done this demo before, so Rolly's in our knowledge graph at this point. But I'm going to use these three examples to learn how to recognize him now. So I go ahead and create a model. When I go in here, these are all those templates that we provide to let you create different types of models for different purposes. And these are really important for some of the stuff I'll talk about in a minute. Like you can run workflows where you have an AI model that outputs predictions with confidence scores. You can threshold those with a concept thresholder, and then you can write them to the database with an annotation writer. So this workflow would be useful for automating the data labeling pipeline. So these annotations get written as if a human did it themselves. So that's how we can make data labeling over 100x faster than humans alone. Now, if I want to teach the system how to recognize Rolly, I'm just going to create a context-based classifier. I'm going to give it a name and an ID. And I'm going to add the one concept of Rolly in here. There's a bunch of other advanced features. This is where the data scientists can tune, based on their expertise, more criteria for the model. When I create the model, it creates a unique hash. So it's just like committing a line of code in Git. You get a unique hash. Every time you train a model, it creates a hash. It queued up the model for training, and now it's complete. So that's how fast we taught the system how to recognize my dog, Rolly. Now, as I go back in here, we can take a look at some of the model predictions. So here, I'm seeing it's 100% likely, the score on the far right, 1.0, it's 100% likely that the model thinks he's a Rolly. That's the easy examples. The green check indicates that I've manually labeled these, so that's the training data. But if I keep going, this image was not labeled, and it's 100% confident. And so another thing you saw was that I didn't have to deploy this model. It's automatically serving requests immediately after training it. Another powerful feature is that you can search for more pictures that the model thinks are Rolly. So this is actually what the model thinks, is not any more labeled data. So I can take all this collection of data and label them to improve my model and be in this tight loop of improvement. So I can select all of them, label them, hit retrain, wait a few seconds, and then search for more. So this is something we actually patented. It doesn't actually require re-indexing your data, and we're the only platform that has that available. It's just another way that we make AI development a lot faster. Now into the data labeling, this is where we put a lot of effort, and it was an advantage we had having run our platform for about 7 years before we built a specific data labeling product. And so we knew we could automate most of the process. And it's just as I described, you can do auto annotation workflows that let you chain together AI models and thresholders, and then write those predictions to the database. Another way we automate things is that when a human is doing the work, we can assist them. We call that AI assist, and it runs an AI model in real time and overlays the boxes or polygons or classification labels so that they can just accept them and move on. So there's lots of different ways of speeding up humans. And like I said earlier, you can use that with your workforce, or if you just want to send us your data and don't care about doing the work or managing the human workforce to do that work, then you can use our label force. So let's take a look at what this looks like. So here's what Scribe looks like in our platform. And here's an example where we have these different concepts you see on the top right: cyclist, dog walker, jogger, and we want to be able to label them. We have a bunch of controls in here to improve the contrast and brightness and even invert colors, so that it makes it easier to see, hard to spot content. And this is really important, especially when you work on small objects or things that are in like infrared and other kind of spectral domains. We also have keyboard shortcuts so that when humans are doing the work, it's much more efficient. And they can keyboard shortcut all the way down to the concepts. You can see those numbers on the far right, 1, 2, 3, 4, 5. That's the concept that you want to label. And then we also have interpolation. So here you're seeing we're labeling a jogger. We labeled the first frame and the last frame, and now we're just adjusting middle frames. And then every frame in between is going to get a bounding box automatically. So if we play back the video, we did about 20 times the amount of work than actually was necessary. So super efficient here at labeling lots of different boxes. Another video here is showing the AI assistance. So here we have a model that's already overlaying some of the concepts that we care about, like cycling, running, etc. And we can tune a threshold to say, if it's above that threshold, we're going to automatically trust it as running. If it's below the threshold, we're going to treat it as not running. And so you can tune these different things and speed up the process of labeling. And then with some of our latest releases, we've introduced a new tool to improve polygon labeling. This is typically a very tedious process. You have to click and draw every point along the polygon. But now we have tools to be able to recognize visually where things are and automate the labeling process. And there's a variety of different tools. There's magic wand tools like you're seeing here that will do like a flood of similar colors to check to create an entire region automatically. So similar to what you do in kind of like a Photoshop. There's also an AI assisted version where you draw a bounding box and it'll segment out the actual predominant region within that bounding box and predominant object and treat that as a new polygon. So these types of AI assistants really improve the human efficiency by orders of magnitude. So that's why we're super excited to launch Scribe last year and start introducing more and more of these functions along the way. And then finally, I want to show you Mesh. Mesh is a really powerful tool. It kind of takes your production setup to the next level, because instead of just having one AI model, you can treat AI models as building blocks, just like all those templates we have available in our platform, like concept thresholder. We have some alerting functions. We have AWS Lambda functions, so you can write your own logic that will run inside our workflows and be able to do more. And so you can handle a lot of different use cases and really get into powerful use cases. Just to give you a sense of some of the NLP, which you can also use as building blocks within natural language, we have a lot of topic analysis, smart reply functionality, as I showed earlier, text moderation, sentiment analysis, and now named entity recognition. So those can all be building blocks. And it gets really exciting to think about that when you combine visual and text modalities together. So we have workflows that you can do something like this, where you detect where text is as the first stage. We have OCR models that'll convert the pixels within those regions into characters. And then we have NLP models that'll understand characters. So in a single API call, you can actually understand these things together in one shot. And so let's take a look at what that can look like. This could be used to read the text on a billboard with a text-based model from the input picture. And so here we might build out a workflow from scratch that we can actually copy an existing workflow. So this is one we already have pre-configured that has the visual text detection. We have cropping to crop out each region, and then we have OCR. And so that will get the characters out of the image. And then you can add to that an NLP model to aggregate those characters and then understand the character. So all of that can be done in one workflow call. And then the final thing I'll mention is active learning. So now that you have a model, you want to make it better. And so we have two ways that are really powerful in our platform. The auto annotation workflows I've described already with adding thresholders and annotation writers allow you to process the data that's being added to your app and then decide to automatically annotate it or route the remaining stuff that is lower confidence to humans. So that's the process at data index time. It'll run a workflow that's fully configurable to you. Another one is what we call collectors. And the idea here is that you can add a collector to any of your production models, and it'll decide how to collect data from the stream of data going to that model for prediction. Collect that data into your app that you can then use to improve your model. And so we have a bunch of building blocks that are really simple. Like here, you're seeing a random sampler. There's kind of naive ones like that. But you can also add anything that you can add in a normal workflow to the collector workflow. So for example, you can run an AI model and then threshold its predictions. And if anything is still in the result of that thresholding, then it'll collect that image. So you might have a model that is general purpose, like our general model, and you want to build a weapon detector. And you want to see whenever the general model thinks it's a weapon, collect it into my app, and then I can draw bounding boxes around every weapon and build the weapon detector. So that's all possible with configuring a collector in our platform. So this allows you to kind of chain together and complete the circle once you have collectors adding data to an app and an auto annotation workflow in your app, so that when data is added, it actually automates the annotation process. That's the full active learning pipeline. And you can do it all like in our UIs. You don't have to write any code to script this. It's all built right into the platform. So this allows you to make your production quality models even better and with the best possible data, because it's the distribution that you're actually making predictions with. So that's a really powerful feature we have, or a pair of features, collectors and auto annotation workflows. And so with that, I'll jump to the end and open it up for any questions. We also have our annual conference coming up October 20th to 21st. So it's called Perceive. You can go to that link there and register. It would be great to see you all there.
Thank you, Dr. for the insightful talk. If there are any questions, we can discuss. Dr. Matt, I had a question. So do the customers require explainability in inference? What contributed to the labels and final inference?
Yeah, great question. And I actually didn't really touch on this, so that's a perfect question. So if I look at this app, so this is an NLP app where we've trained a model to take archive abstracts out of the research papers and then try and categorize them into like biology, chemistry, etc. So if I go look at the versions of this model, I can see that I've trained a few different versions, but I've also evaluated them. So you can hit this evaluate button. Now, if I go look at the evaluation metrics, this shows a whole table of results. For every concept, you get to see true positives, false positives, precision recall rates. For the overall model, you see that too, as well as the ROCOX score. Then you get to see confusion matrices and co-occurrence matrices. And then below, you see precision recall curve. All of these are dynamic, so as I change the threshold at which I would operate this model at, I get to see where everything modifies. That includes even the tables, they all update dynamically. And then I can see specific examples that might be confused based on what I'm selecting in the confusion matrices. So this helps me explain why the model is doing certain things, why it's performing well, and it educates me on, clear ways to improve the model. Like physics and chemistry are often confusing, so maybe I should go label additional data that tease that apart.
Thank you so much. We have a question from Eugene. How can you control improve model fairness in the produced models?
Yeah, I mean, I guess it would be the same kind of process, looking at the distribution of data, which you can see when you look at counts of data, you can see how much is in each category of labeled data, and then how often things are confused. And I believe this one updates as we change, So as you change the threshold, you get to see this as well. So this could be used to balance the performance across different categories to work towards a more fair model.
Right, thank you. Another question from Suni. What's the customer adoption like, and what segments are early adopters?
Yeah, so we have over 100,000 people on our platform at this point, and it ranges from early adopters building things. The nice thing is that we have a self-serve product. You can go to clarifai.com and sign up directly. So you can create an account without even having a credit card and use our free tier to start playing with all these different tools. Once you hit a threshold there in terms of operations per month, then you can, add your credit card and pay as you go. You don't have to talk to our sales team to get up and running. So a lot of developers love that route, and we love supporting them because they educate us on new use cases, and they, build really cool stuff. Once you get into, production, you probably want to talk to our enterprise team, get some advanced features, get additional support from the team. And that's where people like Lowe's, Stanley, Humana, Fortune 500s, and large government agencies are leveraging Clarifai every day.
Sure, thanks. I think we'll take one more question from Marina. Are there pre-trained models for specific domain, example, satellite images, multispectral images, more than 3 channels, etc.?
That's a great question. For some of the satellite stuff we do with the military, a lot of that data is either classified data or it has to remain on government data centers. And so for some of those models, we don't have pre-trained available for the public space, but we have models trained. If you are a government agency, you can reach out to us and we can give you access to that. For satellites, multispectral, and even synthetic aperture radar, we're getting into now. Thank you.
I think we're at the end of the talk. On behalf of MLOps World team and everyone here, I would like to thank Dr. Zeiler once again. I encourage attendees to visit our partner booths to enter in some exciting giveaways. Okay, see you in the next sessions today.
Great, thank you.